Hello viewers, I'm Joseph Opati. I'm math teacher in Boqol Academy. Now today we're going to cover a topic called calculus. It's a Form 4 topic. Now calculus entails the following three topics: differentiation, integration and area approximation. Now before I introduce that, there's something you need to know. As a Form 4, most Form 4 topics are basically revision. They either pick from a Form 1 topic, a Form 2 topic, or a Form 3 topic. For example, the first Form 4 topic is called matrices and transformation. Transformation is covered in Form 2, where we have translation, reflection, rotation and enlargement. Matrices is covered in Form 3 during second term, actually a second term topic. Now, Form 4 we combine the two to have matrices and transformation. Now, we have statistics 2 as a second topic in Form 4. Remember, you covered your statistics 1 in Form 2. Now, calculus is a topic whose foundation is covered in Form 2 in a topic called gradient and equation of a straight line. Then you go to Form 3, a topic called graphical methods. To be specific, a part called rate of change. So I'm going to begin with rate of change and then connect, of course, the two with what? The topic, Form 4 topic, calculus. So that's our beginning point. Number 1, we have rate of change. So what is rate of change? Now, the term rate of change is used, of course, in this topic and the Form 3 topic, graphical methods, to mean what? Gradient. So rate of change and gradient have the same meaning. So we are saying rate of change. Rate of change is equal to what? Gradient. Rate of change is equal to gradient. They have what? The same meaning. Now, gradient is something you covered in Form 2. Gradient was actually means what? The degree of the steepness of a given slope. So given a slope, for example, I can call that slope A, and then I call this slope B. If you're very keen in terms of their steepness, the slope B is more steep than slope A. How we compare the steepness of slopes is what called what? Gradient. Meaning, eventually, if you find the gradient of slope B, it must have what? A higher value than gradient of slope A. So, in Form 2, how were we getting the gradient? Of course, if you remember very well, the formula of gradient was given by m is equal to what? Change in y over change in x, where the significance of m here is that m is the gradient. Then this symbol is called delta, delta y over delta x. Delta is a symbol used to denote change. So we have change in y over change in x. Now, to obtain change, you need to compare some two value. For example, if a student got 40 marks in test 1 and then they end up getting 46 marks in test 2, what is the change? I compare the marks of the two tests and possibly find what? The difference. The change here is what? 46 minus 40 to give you what? 6. So the same argument will be applied here. For me to obtain a change in y and corresponding change in x, I must have what? Two values of y and two values of x. That means the formula can be extended to y2 minus y1 over x2 minus x1, or y1 minus y2 over x1 minus x2. Now, in this formula of getting the gradient, I insist we have two critical things. Number one, it is change in y over change in x and not the reverse. A number of times we find students having what? Their gradient being given by change in x over change in y. We are saying that is wrong. And then, number two, the moment we begin with y2 there, I should have what? x2. Maintain that consistency. If you begin with y1, maintain x1. Of course, now in the denominator. So it's y2 minus y1 over x2 minus x1, or y1 minus y2 over x1 minus x2. Now, having, of course, now recall the formula of getting the gradient, we shall go to the subtopic gradient of a line and see what the key things are in terms of what? Gradient of a line. So let's have what? Gradient of a line. Now, the key thing about gradient of a line is that it is always a constant. It's not a variable. We have what we call a variable and a constant. A variable is basically a quantity which assumes different values at different times. On the other hand, a constant is a quantity which assumes a particular distinct value at all times. So gradient qualifies to be an example of what? A constant, meaning for a given line, it can only what? Assume one value of gradient. So the key thing about gradient of a line is that it is a constant. Don't forget that. Let me illustrate that. It means if at all we have our y-axis, we have our x-axis there, then we have a line, let's say, with that inclination. If at all one student was to choose point A on that line and point B on the same line, and then use point A to find the gradient, and a different student use a point E on the same line and F on the same line to find what? The gradient. The combination of A and B used to get the gradient, and the combination of E and F used to get the gradient will give us what? The same value. Therefore, gradient of a line is what? Is a constant. Does not change. You get what? One value at all times. We know such a line, y is equal to 3x plus 4. From your form 2, this is the gradient, this is the y-intercept. For this line, if you use any points on that same line to determine the gradient, throughout, you're going to get what? The value 3. So, gradient of a line is a constant. That's the second thing we have looked at, of course, in our introduction of calculus. We go to the third item. The third item will be in regard to the nature of the gradient of a straight line. So we have item number 3, nature of gradient. Nature of gradient of a line. Now, under this, we are going to discuss 4 critical points, which now I'm saying will be able to form a good foundation for our Form 4 topic, calculus. Now, these are the 4 points. Number 1, whenever you have a line sloping downwards from left to right, such a line will have what? Will always have a negative gradient. A line with this inclination. So I have my y-axis, I have my x-axis. So any line with this inclination will always have what? A negative gradient. So we are saying in this case, the moment you find the gradient, meaning change in y over change in x, whatever value you get will be less than 0, implying it's going to be what? Negative. Something you covered in your Form 2, but we're just having a quick recap of that. Now, Roman 2, our second point, a line sloping downwards from, of course now, right to left, will have what? A gradient which is positive. So we are saying a line with this inclination, actually the reverse of what? The first line we had here. Such a line will have what? Will have a negative gradient, meaning the change in y over change in x will be, that should be the reverse, greater than 0. So here we have what? A positive gradient. Here we have what? A negative gradient. Keep in mind, I'm focusing on what? Gradient of a line, implying in each of these cases, the gradient still remains to be a constant. We go to our third point in regard to the nature of gradient of a straight line. A line with this inclination, talking about what? A horizontal line will have a gradient that is equal to 0. So here, our change in y over change in x is equal to 0. I've been trying very much to give the nature of the gradient in reference to what? The value 0. Here we have less than 0, implying a negative value. Here, greater than 0, implying positive. Here we have what? Equal to 0. The guys doing business studies, you can remember the demand curve and the supply curve. Supply curve has a positive relationship, always having what? That inclination. Demand curve has a negative, of course, now relationship, having this inclination. Now we go to the last and fourth, of course, nature of the gradient of a straight line. I can just quickly be able to squeeze it here, or let me have it here. So we have Roman 4. We have a line with this inclination, a line which is vertical. Now, a vertical line will always have a gradient which is undefined or infinite. So change in y over change in x will be infinite. So we are saying these key points will be very critical as we proceed to introduce and go deeper into what? Calculus. So a quick summary, we are saying a line whose inclination is like this, a line sloping downwards. Of course now, from left to right, will have a negative gradient. A line sloping downwards from right to left will have a positive gradient. A line which is horizontal will have what? A gradient whose numerical value is 0. Lastly, a line which is vertical will have a gradient which is undefined or infinite. If you are keen, when you are getting gradient in such a case, you end up with 0 over something. Meaning what? You'll get what? A 0 value, because throughout the value of y is the same, but now we have a variation in the value of x. In this case, you'll get something over 0. Now throughout in this line, the value of x is of course the same, but we have what? A variation in the value of y. So 0 gradient meaning 0 over something. Here we have what? Undefined or infinite gradient, meaning what? Something over, of course, over 0. So we are done with the what? The issue of nature of gradient of a straight line. Now we go to rate of change or gradient of a curve. This is our fourth concept, as we of course now go deeper into our topic. So fourth concept, we have rate of change, which I've said has what? The same meaning as the term gradient. Rate of change of a curve. Okay, now how does the gradient or rate of change of a curve, of course, now differ with that of a straight line? Remember, the first key thing I mentioned in regard to the rate of change of a line was that it is a constant. Now, when you come to a curve, we have what? A different case. For a curve, the rate of change is not a constant, but varies from point to point. So here we are saying what? Gradient of a curve is what? It varies. Let me say it varies. It's not a constant. So the issue is, if at all it varies, how is the variation like? Something you want to cover. So gradient of a curve, we are saying, varies from one point to another. Number one, in terms of the magnitude or size of the gradient, and number two, in terms of the signs it assumes, either positive or negative, or zero in some cases. So I will be able to give 4 variations in terms of what? The gradient of a curve. Now, this is the first variation of the gradient of a curve. So we are having our first curve. That is the x-axis. That is the what? Y-axis. Now, if I have such a curve, clearly see we have what? Variation in terms of what? The gradient. Because here we are having a different inclination from that side. So how is the variation? We are going to pick from the idea of what? The nature of gradient of a straight line. If you remember, just a quick review. For a straight line, we said what? We have a negative gradient, we have positive gradient, we have zero gradient, and we have what? Undefined gradient. If you are keen on this curve between that point and that point, the inclination is similar to this inclination of this straight line, where we said the value will be what? Would be positive. So here we have what? A positive gradient. Now, between this point and that point, if you look at that inclination, is similar to what we are having here in terms of what? This straight line. And here we said such inclination means what? We have a negative gradient. So we have negative gradient. Now, at the top part of the curve, just somewhere there, we are saying the inclination of the curve is almost horizontal, similar to what I'm having here. We said, what is the gradient there? The gradient is 0. So we are having the variation from positive to 0 to negative. That's the first word, variation in terms of the gradient of a curve. Now, we go to the second variation. Just insisting on the fact that a line has what? A constant gradient, but a curve will have a gradient which varies from point to point. So we have y-axis, x-axis. I'm going to have basically a reverse of that in terms of how the graph is curving. Here it was curving downwards, here is curving upwards. Now in this second case, what is the variation like? Very, of course, now simple, having done what? The nature of gradient of a straight line. If you're very keen, this inclination of the curve between this point and that point is similar to that. What do we have? We have a negative gradient. Now, between that point and that point, what is the inclination like? Of course, similar to what I'm having here, implying that is what? A positive gradient. At the bottom here we have what? An inclination which seems to be parallel to the x-axis, implying a line which is horizontal. Therefore, we have a 0 gradient. Now, of course, now furthering the concept that for a given curve, the gradient is not a constant but varies from point to point. Now, we go to our third variation. So remember this point, gradient varies, of course, from point to point. Now, our third variation will be something like this. We have Roman 3. So, y-axis, x-axis. Now, this is how we can have the variation. Of course, now in the third form, we have that inclination, we turn, then we continue. So how is the variation like here? If you're very keen, between here and here is the same as that variation. Meaning what we have? We have a positive gradient. Now, at the point where the turning occurs, it's like our curve is horizontal. We have a 0 gradient. Then after turning, if you're very keen, the same trend as the initial trend is maintained. So what do we have? The originally positive gradient trend. So we have positive, 0, positive. Then our fourth variation, then we can go to something else. Again, y-axis, x-axis. So we have that inclination, we have a turning, then maintaining the original trend. So what we have here? We have negative gradient. We have 0 gradient. We have negative gradient. So these are the 4 different variations which the gradient of a curve can take. So the first variation, in summary, we have a change of the gradient from positive to 0 at the top there to negative. We have our second variation from a negative gradient between this point to 0, then to positive. Actually, the reverse of the first. Then our third variation, what we have? Negative gradient, 0, then changes back to what? Positive. Here, our fourth variation, we have negative. We have 0, then negative. Now, having discussed that, we want to discuss the next issue, which could be a challenge. The question is, if at all you are required to get the gradient or rate of change of a curve. How will that question be framed? Of course, now you cannot get such a question in the exam as find gradient of the curve. That will be an ambiguous question. Why? The moment I ask you find the gradient of the curve, now a number of you maybe will focus on this side, a number of you on that side, maybe somebody else there. So it won't be, of course, now a good question. So the question is, the moment you get a question in the exam in regard to the rate of change of a curve or gradient of a curve, how is the question framed? So we are saying the question has to be what? Has to be specific. The gradient of a curve is normally specified in terms of the following two items I'm going to mention. Now, let's quickly discuss that. That is point what? Point number 5. So point number 5 is basically dealing with what? How the gradient of a curve is normally specified or how it can be determined. So how is it specified? It is specified in the following two ways. Number 1, either what we call average rate of change. Average rate of change, something I'm going to clearly outline in this particular, of course, space. And number 2, we can have what we call instantaneous rate of change. Of course, just doing a quick recap of Form 2, Form 3 work. Now, this is Form 3. Then we shall go to our topic, calculus. Now, so gradient of a curve or rate of change of a curve must be specific in any, of course, question. You either ask about what? Average rate of change or about instantaneous rate of change. Now, at this point, we want to clearly outline or explain the difference between this and this, of course, in regard to rate of change of a curve. So, what is average rate of change? You listen. Average rate of change is the gradient or the curve. Is the gradient or the rate of change, of a curve between 2 points on the curve. I will repeat. Average rate of change is the gradient or rate of change of a curve between 2 points on the curve. Let's say I have what? A curve, and I have 2 points, point A and point B on the curve. The moment I get the gradient between point A and B on this curve, it becomes what? Average rate of change. Now, we go to what? Instantaneous rate of change. Now, what is instantaneous rate of change? It is the rate of change or the gradient of a curve at a particular point on a curve. So I'm having a curve. Then I have a particular point which I'll call point. Let me use point what? Point A. So average rate of change and instantaneous rate of change. I will discuss the difference. The difference is this. For instantaneous rate of change, the focus is on a particular point, a single point on the curve. What about average rate of change? The focus is on 2 points, of course, on a particular curve. So again, I'm saying average rate of change is the gradient of a curve between 2 points on that particular curve. And instantaneous rate of change is the gradient or the rate of change at a specific, at that instant, specific point on that curve. Now we go to the other issue. How can we obtain average rate of change and instantaneous rate of change? Very, very simple. For the average rate of change, to obtain that, you take a ruler, connect the 2 points with a straight line. Then simply find the gradient of the line connecting the 2 points. So I've got point A and point B connected by this straight line. So we are saying that connection will give us, of course, change in Y, and we have what? A change in X. So given the fact that you know the coordinate of A and that of B, just go ahead and do what? Use the very coordinates to find what? The gradient of that line, and then that will give you what? The average rate of change. Let's assume for point A, the coordinates are x1 and x1, y1. Coordinates of B are given by x2, y2. So you're saying for this curve, the average rate of change will be y2 minus y1 over x2 minus x1. Of course, now y2 being what? The y coordinate of point B, y1, y coordinate of point A, x2, x coordinate of point B, and x1, x coordinate of the point A. So that's how you do what? Determine average rate of change. Meaning what? The rate of change of a curve between 2 points on the curve. Now we go to instantaneous rate of change. The rate of change or gradient of a curve at a specific point on that curve. What do? You take your ruler and place it there and draw a tangent. What's a tangent? Simply a line touching the curve at that point. Of course, try and maintain high degree of accuracy. So we have a tangent. A tangent from your topic, Sec1 chords, is simply a straight line touching a curve at a given point. So you're saying once you draw the tangent, you pick any 2 points on that tangent and then use the 2 points to obtain what? The gradient. Of course, now we shall have change in Y there and change in X there. So in this case, the gradient of that line, which is a tangent, will give us what? Will give us the instantaneous rate of change. So we are done with that. We want to see if I can maybe just quickly go to a topic calculus, but let me give a summary of these two, of course, now concepts here. What do we have here? Average rate of change. What do we have here? Instantaneous rate of change. What are the two key differences? The first difference is that in average rate of change, I am dealing with 2 points on the curve. In the case of instantaneous rate of change, I'm dealing with a single point on that curve. Number two, key difference will be in terms of how you obtain your rate of change. Here, how do I obtain the rate of change? I join the 2 points with a straight line Then go ahead and find what? Gradient of that line joining the 2 points. It gives you what? The average rate of change. What about here? You draw a tangent to the curve at that specific point. Then pick some 2 points. Are we together? Then use them to do what? To find what? The gradient of that line. So the gradient of that tangent becomes what? The instantaneous rate of change, meaning the gradient or rate of change of the curve at that particular point. So having reviewed the gradient bit of form 2 and the rate of change of form 3 under the topic graphical methods, now we can be able to introduce our calculus. And I said calculus has 3 topics. We have differentiation, integration, and a part of what? Area approximation. Sometimes the concept of calculus is included there.